Alright, okay, let's look at this question. This is just to revise how to show that the vectors are parallel. Okay, what is meant by parallel vectors? As you know that if a vector is parallel to another vector, we can write it as a scalar multiplication, right? It's a scalar product. Okay, it's a scalar. Let's say if A is parallel to B, it can relate by a K, right? A scalar, any scalar, any number. All right, as long as you can relate it with the equation with a scalar, or we can say that it's a scalar multiple of another vector, of this vector and this vector, then we can say that these two vectors are parallel. So for example, let's look at this this vector here. So usually I will rewrite this in the column form, okay, column vector form. So if you see that this one, right, this one, you can actually rewrite this. Before that, I can see that where is a common factor here? 1/3, 1/3, and 1/3. So I can taken out the 1/3, right? 1/3. So the remaining inside will be I minus 4j minus with 7k. So okay, now we have this, right? We have this I minus 4j minus 4k, which is A, right? Which is 1/3. I can rewrite this as 1/3 of A, right? Means that as long as you can write A with a scalar, right? Means that, let's say this one, 1/3 of this vector A, right? Then we can say that this vector is parallel vector. Okay, I put a tick here to tell you that it's actually parallel to this vector A, right? Because you can write this as a scalar of this vector. All right. Okay, let's look at part B, right? See whether it can rewrite in the form of this vector or not. So okay, now we refer to this column vector here. We can factorize the 2, right? We can factorize the 2. If we factorize the 2, we have 1, -4, -8, right? 2 times 1, 2 times -4, 2 times -8, -16. 1 -4 is okay, right? 1 -4 is okay, but -7 means that this is not, all right? This, you cannot rewrite this as 2a, 2 vector A, because I minus 4j, but this is -8, right? So this can show that this is not a parallel, it's not a vector parallel to this A, right? Because I cannot rewrite this as a scalar of this vector, right? This is not this vector, so means this vector 2, -8, 16, -6 is not parallel to this vector. So let's look at the C here. Very simple. C is another way, just to remind you that another way of writing a vector, right, in this form. So usually I love to write in column vector. Okay, -21. So I can factor out the 3. Just factor out the common factor here, the highest common factor here. We will have 1 negative with 4, right? 3 times 1, 3. 3 times -4, you have -12. 3 times -7. You can see that 1, -4, -7. 1, -4, -7. So it means that this can rewrite as a 3 times the vector A, right? So this is also a vector which is parallel to vector A, right? It's a vector, but longer. This one have longer. How? Longer. How to know? Because the scalar here is 3. Means this vector is 3 times larger than the magnitude of this vector. Okay, very simple. So okay, let's look at this. Let's look at this. I can rewrite this in the form of column vector if I want. -30. Alright, I just factor out the -5 here. Why? To make it 1 here. I just factor out. So I factor out the scalar -5, and here we have 1. And for this we have -4, right? Because -5 times -5, -5 times -4, I get 20. And okay, 5. This one should be 6, right? 5, -5 times 6, -30. You see, 1, -4, but this is 6. So which is not A, is not, this is not A. After you factor something, this is not a vector A. So means that you cannot rewrite this vector as a scalar of this vector, and we say that this is also not a vector that parallel to this vector A. So there's only 2 vectors which are parallel to this vector, which is the part, the A and the C. Alright. Hope you understand the meaning of parallel vector.